So we saw a simple button in Java. So now let's look at slightly more elaborate examples of how things work in Swing. So remember that we said that Swing is very flexible about connecting events to listeners. So in the button example, we had one button which did one thing and it was listened to by one panel, because it was just a very simple example, and that one panel did one thing that we told it to, which was to paint the background red when the red button was pressed. But one listener can now listen to multiple objects. So for example, supposing instead of that one button we had three buttons in that panel, right? It had a button labeled red, a button labeled blue and a button labeled yellow, right? So we have three buttons now in the panel, and of course now the interpretation of this is that the label indicates what is to be done. So each button generates an action performed event, and that has to be handled, an action event, and that, so it generates an action event and that has to be handled by an appropriate listener which is doing action performed. But we want to do this all in one panel. So this panel should now listen to all these three buttons and do the appropriate thing. So we have this one panel as before, which is a J panel which implements action listener, but now it has three types of buttons, and now it must disambiguate when it comes to action performed which button was clicked, right? So I make the panel listen to all three buttons, right? So I add to each of the buttons, I add the action listener to be this current panel, the embedding panel, right? And then I add all the three buttons to the panel. So up to this point there is no problem, but the problem we have to now do is to decide how to implement this action listener part, so that if I get a button press event from the yellow button, I must turn it yellow, from the blue button I must turn it blue, and so on, right? So this is where we said that the event actually is an object. It has structure and it has information in it, so we can analyze the structure. So one of the things that we can analyze is which button was the source of the event, right? So we can get from an event, so this is the action performed now, so it gets this action event, and what it does is it queries it. It says what was the source of this event, right? So the source of the event is some object, right? And now remember that this is all sitting inside the same button panel. So the same button panel now has these three buttons. So these are all local instance variables of this button, right? So these are known to it. So this button panel will now ask itself, is the source the yellow button, or is the source the blue button, or is the source the red button, right? So if the source is the yellow button, it will turn the color to be yellow. If it's the blue button, it will turn the color to be blue. If it's a red button, it will turn the color to be red, and then it will set the background color. What if it is none of these three? What if there was a button, maybe it is getting somewhere else it is also listening to other things? Then that should not affect the color. So what we do before this is we get the existing color, so that this color variable has the current color as the background, and then if these three ifs all fall through without triggering, then we will just go back and restore the old color, right? So the default is to restore the old color unless exactly one of these three events. Now the reason is that because now we have shown in this case that a listener can listen to more than one button. So here we are listening to these three buttons. Maybe this listener is also listening to buttons from elsewhere, and those buttons should not change the color of this panel. Okay, they have some other effect. So therefore we have to have this background thing of keeping the color the same in case there is no change. And finally we repaint. Right? So this is just an extension of the single button case. In the single button case, we did not have to analyze where the event came from, because it came from only one button. We are only listening to one button. If that one button is pressed, we painted the background red. Here there are three buttons. So when we get an event, we have to first check which of these three buttons it was by checking its source, and depending on what the source corresponds to, we will choose the appropriate color and then repaint. So this is what this thing looks like. Of course, then you have to take this panel and put it in a frame and so on, which is exactly the same as with the single button case. So I have not shown you the code for that, but there is essentially no change except you have to obviously create an object of this type rather than the other type. So now when we start up this thing, we have a kind of, by default, Swing puts this gray color panel, it looks like, and it shows you these three buttons. Remember the buttons had these names, right? Yellow, blue and red. So it puts these three buttons, and it kind of automatically decides how to position them. So it puts them side by side, depends on the size of the frame and the size of the thing that you are making visible, how it will put them. If you make a frame very narrow, it might put them one on top of the other and so on. Now when we press the yellow button, right, we get a yellow thing, and you can also see that the yellow button has a indication that it was pressed, right. And now when we press the blue button, then the background turns blue because that's what the listener says. And notice that we have an indication on the screen that the blue button was pressed, and same for the red button, right. So it should also be red, but something is wrong. Okay, so the same thing will work for the red button as well. So now this is an example where we had one panel listening to 3 buttons. So we had multiple generators of events and a single listener. Now what if we have 2 panels, right, and each panel has 3 buttons of the same type, red, blue, yellow. But now the twist is that if I press the red button in one panel, it must change both panels to red. If I press the yellow button in any panel, it must change both panels to yellow. So the event now must notify not one object but 2 objects. Earlier we had one object which was listening to multiple buttons. Here we have one button which must tell multiple panels, right. So this is what is called multicasting, right. So multicasting says that we have multiple listeners for an event. So this is an interesting idea that we don't have to just send the signal in one direction, we can send it to more than one, right. So here is our thing again, right. So we have this 3 buttons, right, and we are going to add them, right. But between that we have to do something about setting up their identity so that we can do this. So now both panels must listen to all 6 buttons. So there are 3 buttons on one panel, there are 3 buttons on another panel, and all buttons must be listened to by both panels. But each panel only knows about its own buttons. So we can't use this get source to refer to buttons which are from the other panel because we don't know their identity. The objects in the other panel are not known to this panel. So how do we determine the source of an event from a button which is on the other panel? So remember, there are 2 such things, right, and each has one copy of the buttons. So you don't have the identity, they are private to the other panel, you don't have the copies of the other things available to you. So what we can do is we can associate a label to the event. Earlier we were looking at the source of the event. So now in some sense we are attaching a type of our description. We are attaching a description to the event, okay, which is called an action command. So we are saying pressing this button conveys this string. So the strings that we have correspond to the colors that we want. So capital yellow, capital blue, it could be anything, but it's something now where now when we get the event, we can ask what is the action associated with this event, and it will tell us the action is either the string yellow or the string red or the string blue. So now if I look at the other side, if I look at the action performed thing, instead of asking for the source as we did before, now we will say from the event which I just received, give me the action command, and this is a string. So I store it as a string locally, and then I compare the string. If the string is yellow, then set the color to yellow and so on. And as before, we start with the background color here, so that if it's not one of these 3 things, I don't change the color. Otherwise, I change the color according to the string that I get from the action command, and then I set the background color and I repaint. Right? So there is one more thing, which is I have to make sure that each button notifies both the panels. So earlier, if you remember, we had done that right at the time when we set up the button. So if you go back here, right, when we created the button, before we created the button, we just made the enclosing panel a listener. But that's not enough, because I also need to make the other panel which is not known to this panel at this point a listener. So that's why we did not put this here. See, this is a place where we would have associated listeners, but we did not put it here, because at this point we can't just associate this panel, we have to associate both panels. So the solution to that is that we actually create a separate public function inside this panel class, which allows it to receive the name of a button to which it must listen. Right? So we can add a listener. So earlier we had a button to which we added a listener. Now we are adding to the listener we are adding a button, right. So what we say is that if I get a button, sorry, I'm adding, I'm adding a panel to a button. So I give you a panel, and what it does is it adds that panel to all the 3 buttons, right. So we have this add action listener which takes one button and associates a listener. Now we want to associate this with panel 1 and panel 2. So I will call this function once with this panel and once with another panel, okay. So if I look at now how I create this inside the frame, now the frame changes a little bit, because in the earlier case I just had to create a panel and be done with it, because the panel set up the listener itself. But now the frame has to do this extra work of connecting each panel to the other, right. So I create these 2 button panels. So this creates 3 buttons in one panel, 3 buttons in another panel. Now I have to tell these 2 panels that each button in your panel has to listen to the other thing also. So I have to take B1 and add itself as a listener. So the B1 buttons all talk to B1 panel. I have to take B1 and add B2 as a listener. So the B1 panel also notifies all the B1 buttons also notify all the panel B2. And similarly B2 has to notify B1 and B2 has to notify B2. Right. So each button, now the frame has the job of creating these 2 panels and telling these 2 panels to talk to each other. That is, every button in your thing must talk to the other guy and yourself, and vice versa. So this is what sets up the multicasting. So the multicasting is not set up in the panel itself, but by the frame that creates the panels. Okay. Now there is another small thing. We talked about the layout. We said when you put 3 buttons, it really depends on how these things are positioned with respect to the size of the frame. So you can add some extra information to the frame. So for instance, you can tell the frame that you want to lay it out in a particular way so that you can position things in the frame. So this has something, you can look it up in the Java documentation what kind of layouts are there, but the simplest layout allows you to put something at the top, bottom, east and west, or left and right. So it's called north, south, east, west. So it says the first panel I'm going to put in the north, and the second panel I'm going to put in the south. So at this point now I have created 2 panels, I have made them talk to each other, and I have positioned one on the top, one on the bottom, and each of them, when it receives an event, it will look at the type of the event as given by the action command. Whether it came from its own button or from the other side, it will look at the string it gets, yellow, red or blue, and do the appropriate thing, right. So this is how it works, right. So first of all, you can't see the panels right now, but there is an invisible line here and here which corresponds to the boundaries of the 2 panels, okay, because I have pushed one to the north, one to the south. So there are 6 buttons, 3 belonging to the panel 1. So this is my B1, and 3 belong to the panel 2, and each of these talks. So this red talks to here and talks to here. This blue talks to here and talks to there. This yellow talks to itself and talks to here, right. So each of these buttons notifies the panel in which it's sitting and the panel on the other side. So if for instance I press the yellow button, then both these panels become yellow, and now I can see the boundary because only the panel part is yellow. So this is the part in between which doesn't belong to either panel. Similarly, if I press the blue, then both of them become blue, and if I press, so now I also want to emphasize that here the yellow on the top was pressed, right. You can see the square around the yellow. Here the blue on the bottom has been pressed, right. You can see the rectangle around the blue, and now I press the red on the top, right, and again it works. So I press either one, and according to the label on the button that I see, it generates internally a string of the type that the panel understands, and that panel will decide based on that string which color to change the background to. So this is multicasting, right. So you can take one event generating object and spread the event effect to multiple listeners. So finally, we've been working only with buttons. So just to illustrate that this is a kind of generic toolkit. So Swing has objects of various different kinds that you would want to put into a typical graphical user interface. Let's look at something called a checkbox, right. A checkbox is just a box that can be ticked. If you have ticked any online form, you have seen this. You can tick one or both or any, right. So it's not like a button where if you select it, the other becomes unselected. So let's look at something which has now 2 checkboxes, one called red and blue. And now the thing that we will ask is that if the red is ticked, then make the panel red. If the blue is ticked, then make the panel blue. But because it's not exclusive, it could be that both red and blue are ticked, in which case we will make it green to indicate that both have been ticked. Okay, so this is the desired behavior. We have 2 checkboxes, and if both are ticked, then we'll make it green. Otherwise, we'll change the color according to the one that is ticked. Okay. So first of all, we have to have a way of indicating whether a checkbox is ticked or not. So a checkbox, first of all, when it is ticked, it generates an action, an event which is an action listener like a button. But the checkbox itself, now unlike a button which every time I click it, it gets clicked and then it remains in the same state. So I can click it again. A checkbox is not like that. If I tick it, then it becomes ticked, and if I tick it again, it becomes unticked. Right? So I have to remember whether the checkbox is ticked or not, which is normally called selected. Right? So whether the checkbox is selected or not. So when I create this, I set up these two boxes which are, like we said, like J button, J panel, J frame, the J checkbox. I set up these two buttons with the appropriate label. I make them both talk to the enclosing panel. I initialize them both to be unselected, right? And then I add them to this panel. So that is the first part. It's simple enough. It's like adding two buttons, except I'm adding two checkboxes. And unlike two buttons where I don't have to say anything more, when I add a checkbox, I have to decide in the initial state whether the checkbox is selected, that is ticked, or it's not ticked. So now in the listener side, right, the way it will get, when it is notified, it has to see what was selected, right? So the action performed, it doesn't have to do anything really with the event. It will rather look at the state of the checkboxes in this case. So it will say if the blue box is selected, then set the color to blue. If the red box is selected, set the color to red, right? So if either of these is selected and only one of them is selected, then if it is blue, it will set to blue. If it's red, it is set to red. And then it will say if both are selected, right, then set the color to green. And as usual, we start with the existing background color and then we replace it. So in particular, what this means is that if I had, say, the red checkbox and the blue checkbox, right, and then I did this, so then I made it red. Then if I uncheck this and make it again empty, it will remain red. Why? Because it now red is not selected, blue is not selected. So it was red, so it will remain red. Similarly, if I make the blue, if you make it blue by ticking blue and then I untick the blue, it will remain blue. Okay, and if I tick both because of this and, it will make it green. Right? So this is how it looks, right? So we have a checkbox, the frame sets the label on the top, and it has these two boxes in which I have this place which I can go and select, right? So I can go and make this an X, for example. So if I make the red an X, if I tick the red box, then I will get a red frame. If I tick only the blue box, I will get a blue frame. And if I tick both the boxes, I will get a green frame. Right? So this is just to illustrate that you can easily program things other than buttons. So checkboxes, you can make lists, you can make radio buttons, you can do various things. Just everything that you normally see in a graphical form or in a graphical interface is actually available in Swing for you to program. Right? So the summary is that Swing has this built-in notion of components, and these components like buttons and checkboxes and so on generate these high-level events depending on what type of object they are. And each event is automatically sent to a listener that is listening, and what the listener is supposed to do is described through an interface depending on the nature of the component that you have, right? And the listener can now take this event that it gets. When the event happens, it's an object, so it can look at this event and analyze it. It can say where did it come from, what is the action label associated with it, and so on, and react accordingly. Right? So this association is flexible, as we have seen. You could have one is to many, many is to one, so you can have multicasting, all these things, but you have to do it explicitly. Right? So if you do not connect a component to a listener, then the component's events will get generated and will just disappear. Right? So nobody is listening to them, they will get lost. So this is what we said, you will get an unresponsive button, for example. Nothing happens because there's nobody listening to it. So you have to be, it's the programmer's responsibility to do this. Right? So this is not true in all other programming languages. In some programming languages, there is an implicit connection, that is, the something that creates a button will also listen to it. So you will always be guaranteed that there is a listener, but then you lose some flexibility. So this flexibility actually gives you the most general setting, and then when you go to other languages, you have to look at which level of flexibility that language supports. So it is typically not the case that people program graphical interfaces in Swing, because Swing is not, as we have seen, it's a little cumbersome to do, and it's also aesthetically not the most pleasing design. So you don't have much choice about layout and colors and shades and shapes and so on. So if you really want a cool looking design, which appeals to a graphic designer, swing is not probably the best thing to do. So we are not discussing swing as a graphical design tool, right, to lay out beautiful web pages, but to illustrate that it has all the principles that you need to understand how these things work. What happens when you set up a graphical page, right? You have these components, you have these listeners, components react, generate events, listeners react to them. And once you understand this, then you can pretty much understand the setup in any programming language or any kind of platform which allows you to design these things, because they will all be there in some form, usually less flexible than swing, but possibly more aesthetically controllable.